Hi there, folks. Today we're looking at number operations just in general, doing operations with numbers and following order of operations, that kind of thing. So the heart of this and really what we use it within the context of most of the time is order of operations. So order of operations here, I go with IRMDAS, inclusion symbols, exponents and roots, multiplication, division, then addition and subtraction. And I always write it stacked like this with the E and the R, the M and the D, the A and the S, because those are tied. They are at the same spot in terms of order of operations, and the tiebreaker is you always go left to right. So like addition and subtraction, you don't always do addition first, okay? You do addition and subtraction as the last set of operations, but you do those left to right. So you might do subtraction before addition. Same thing with multiplication, division. They are tied in terms of order of operations. The tiebreaker is left to right, okay? So let's jump into a couple of these. If I look at something like this, first one, 9 times 1/3. So just a reminder of fractions. Remember, a fraction bar is a division sign. So this says times 1 divided by 3. Okay? So 9 times 1 divided by 3. And you can do 9 times 1 and get a 9, and then divide it by 3 and get a 3. You could also do 9 divided by 3 and get a 3, and then times the 1. And so, again, when you're looking at these, it's just times this divided by this, all right? The multiplication symbol goes to this guy, and then this is a division symbol right here. So it's time 1 divided by 3. You can do the division first. Same thing with the next one. That says times 1 divided by 4. I could do the division first. I could say, hey, divided by the 4 first. So negative 12 divided by 4 is a negative 3. And then times 1 is still a negative 3. Okay? But again, it's times 1 divided by 4. If you look at the next one, same thing. It's times 3 divided by 2. All right? And so you think of it in terms of those operations, and you can do the division first or the multiplication first because they're happening at the same time. So you could do 8 times 3 is a 24, and then 24 divided by 2 is a 12. You could also do the division first. 8 divided by 2 is a 4, then times the 3 is a 12. But that's what a fraction is. It's just a division sign, so it's multiplication and division happening at the same time, okay? If I look at something like this guy, order of operations, in IRMDAS, inclusion symbols are like parentheses, brackets, braces, absolute value. So I start inside the parentheses. So inside the parentheses, I do this subtraction first. That gives me a 4. And now everything inside the parentheses is done, so all I have is an exponent and division. I do the exponent first, so I do the exponent. That's a 64. And now I do the division. That's a 32. Okay? If I look at the next one, I have an exponent, subtraction, and I have division, but I also have parentheses here. Okay? Anytime an operation is happening to a bunch of stuff, that stuff is in parentheses. And so once again, look at this bar right here. That fraction bar is a division sign, but that's happening to all of this stuff. It's 2 to the 4th power minus 1, and that whole thing is divided by 5, which means that whole thing is in parentheses. The parentheses are implied. We can't see them, but we know that they're there. There's parentheses there. I'm saying that whole thing divided by 5, so that thing is in parentheses. So I start inside the parentheses. Inside those parentheses, I have an exponent and I have subtraction. So I do the exponent first. So 2 to the 4th power is a 16. Again, I still have those parentheses that weren't originally written there. All right. Inside those parentheses, I do the subtraction next. That's a 15. And now I can do that division, which is a 3. Okay? If I look at the next one, I have parentheses, but there's nothing inside those parentheses, so we don't have to worry about that. I do have to understand that this is 4 times that. So when we see something written side by side, it's just multiplication that's implied. So I have an exponent. I have multiplication, I have division, I have subtraction. I start with the exponent. So I'm going to do the exponent first. Next, I would do multiplication, division, and here's where that tiebreaker comes in. Notice I have division here, and I have multiplication here. Multiplication and division are tied in order of operations, so I have to go left to right. And so in this scenario, if I go left to right, the division comes first, so I do the division first. Okay? This is the scenario where I do division first, so 16 divided by 4 is a 4. And now I'll do that multiplication, 4 times 2, which is an 8. And now addition and subtraction are tied. The tiebreaker is left to right. And so it just so happens the addition does come first, going left to right, so I do the addition first. And now 17 minus the 27 is a negative 10. Okay? But again, if you did the multiplication first, you would have done the 4 times 2 and gotten an 8, and then the division 16 divided by 8 and gotten a 2. That would be completely wrong because we didn't follow order of operations correctly, okay? Multiplication, division are tied, so when there's a tie, you go left to right. Addition and subtraction are tied. When there's a tie, you go left to right, okay? If I look at the next one, I threw a radical in here. There's a root, that's square root of 9, all right? Just to show you that it falls in the same spot of order of operations as exponents. So here I have exponents, I have multiplication, I have a root, I have subtraction, I have addition. I do the exponents and the roots first. And again, you go left to right on this. So I would do the exponent first because it's to the left. So that's a 36. Minus 2 times, well, I have now worked my way to the right, so I can do this square root. The square root of 9 is a 3. And now I have to look at this. I have addition, subtraction, multiplication. I do the multiplication next. Now addition and subtraction are tied, so I go left to right. The addition comes first when I'm going left to right, so that's a 51. Or sorry, a 51. And now I do the subtraction. I get a 45. Okay? If I look at the next one, again, I want to follow order of operations, but I have to substitute these guys in first. Anytime I plug stuff into an equation of some kind or an expression of some kind, anytime I substitute in, I use parentheses to substitute in. It's a great idea. So here I would say it's parentheses squared plus parentheses minus 12 divided by parentheses squared. Okay? Essentially, that's what a variable is. It's a blank space, all right, a blank slot of parentheses, and now I plug in. This one's a 5, this one's a 5, and then over here, the y, that's a 2, okay? And it won't make a huge difference in this particular example, but as soon as we start throwing negatives in there, those parentheses are going to save us, okay? And so here we go. Order of operations, I do the exponents first because there's nothing to do inside the parentheses. Now I would do the division next. And now left to right for addition and subtraction. And that's it. Okay, take it one step at a time. If I look at this one, again, I'm going to use the parentheses to plug this stuff in. So that's sorry, there's a little bit of a typo here. I think I wanted A and B for these. So we'll say this is the 4, and then this is the 2. And again, if I'm starting inside the parentheses, maybe if it helps if I change this set of parentheses to maybe some like brackets or something to make them different, a different set of inclusion symbols. But inside there I have multiplication, so I do the multiplication first. And now I do the exponent. So that's a 64. Okay? This one, percent, remember, is a ratio that's expressed out of 100. So when we say, something percent, it means that thing out of 100. We also then write it as a decimal by dividing by the 100, okay? It moves the decimal 0.2 places. But those different ways of thinking about percent can help us when we're dealing with operations that have percents, okay? So this one, write 25% as a decimal. Well, as a fraction, 25% literally means 25 out of 100. And so now if I were to plug that into my calculator, that gives me 0.25. And that's how we express it as a decimal. The shortcut to that is we just move the decimal spot 2 places, okay? So if I had 25%, so it's 25.0, you move the decimal place 2 spots, so now it's 0.25, okay? If we look at this guy, going backwards here, it says write this as a percent. Well, if you want to write it as a percent, first let's write it as a fraction. 0.82 is 82 over 100. Well, that's 82%. But again, the shortcut, just moving the decimal back and forth, is typically what most students do. We say, hey, 0.82, let's move that decimal 2 spots, 1, 2, 82%. Okay? And that's important because when we do operations with percentages, we typically use the decimal version. Okay? For example, if I look at something like this guy, a student scored a 22 out of 30 on an assessment. What was the student's score as a percent? So 22 out of 30 is a ratio. It's a fraction of 22 over 30. So I do 22 over 30. And really, I just use my calculator for this. So plug it into your calculator here. Let me grab mine. 22 divided by 30. It gives me 0.73 with the 3 repeating over and over again, okay? And so if I just kind of rounded that off, it would be, I'll go 733, something like that, okay? But now I want to write that as a percent, so move the decimal 2 places. 1, 2. And that's the shortcut version. Well, that's a 73.3%. Okay? If I look at something like this guy, 25% of 80. If I want to find a percentage of something, all I have to do is multiply by the decimal version of that percent. So 25% as a decimal is 0.25. So if I want to find 25% of 80, I just multiply that by 80. And then I use my calculator, 0.25 times the 80, and that gives me 20. Okay? And I could easily check that. I could say, oh, is 20 out of 80 25%? You could take it off to the side and do, 20 out of 80, divide it on your calculator and get 0.25. And there it is, 25%. Okay? But again, you want to find the percent of something? Just multiply by the percent. If I take a look at this guy, it says find 62% of 120. So once again, 62% as a decimal, it's going to be 0.62. And I just multiply that by the 120. If I want to find 62% of that value, I multiply it by that percent as a decimal. So 120 times, and this is a job for my calculator. So the 0.62 times the 120 gives me a 74.4. Okay? And again, I could check it. I could do 74.4 over 120. I could divide it and see if it gives me 62%. Okay? If I look at this guy, again, as a decimal, and students get really worried when they see a percent that's over 100. It's still the same thing. The decimal point is here. Move it 2 places. 1, 2. So it's 1.15. Okay? And we use percents that are greater than 100 all the time. When we want to increase the value of something, we think of it as a value of over 100%. Okay? Because it's like we're starting with 100% and we're going up from there. Okay? We're starting with 100% of what we have and we're going up from there. Okay? And so the 115 as a decimal is 1.15. Again, I want to find the percent. I just multiply that 80 times the decimal version of the percent. So on my calculator, 1.15 times the 80, that gives me a 92. Okay? If I look at something like this guy, it says $450 phone is on sale for 64% off. What is the new price? And, when you approach these things, the easiest way to do this is to say, hey, you know what? The original price, what we start with is like 100%. So we start with 100%, and then we take off, we subtract 46%. And so the question is, what percent are we going to pay? Okay? So I always do it this way. I do the 100 minus the discount because that's what we take away. We take away 46%, which means I'm going to pay 54%. So if I want to find 54% of this value, I multiply by the decimal version of that. So it's 0.54 times the 450. Okay? And that gives me 243, and that's dollars. Okay? The other approach to this, and you might feel more comfortable doing this, is you could find 46% of the 450 by doing this. So it's 0.46 times the 450. And so I do that on my calculator. And that gives me 207. But again, 46% was the discount. So the amount that I just found is the discount. That's not what I pay. That's how much discount I get. So now I have to do the 450 minus the 207, okay? And when I do that on my calculator, it gives me a 243. So I still get the same answer, and I still did the same 2 steps. if you noticed in the first example, I just did the first step in my head. I did 100 minus 46, and that gave me the 54% that I started with. So it's still subtraction and multiplication. It's just a matter of what order you're going to do those things in. I like to subtract the percent and then find the value right away. Okay? Some of you might like to find the percent discount and then subtract. Okay? And the only reason I do it this way is because that first step can be done in my head, and then it's easier for me to plug into the calculator. So if I'm actually standing in a store somewhere, this first version is easier to do. Okay? If I look at something like this guy, it says a pair of headphones costs $64.99. What is the price after tax? And remember, tax is a 6% increase, okay? So that's like adding 6%. All right, that's what you do with tax. So once again, if I think about it the first way, and I'm going to do this one twice, if I start with 100% of the value, so 100% of the price is this guy, so that's all of the price. But if I add 6% to that, that means I'm going to do 106%. And so if I wanted to calculate this thing with tax as a decimal, that's 1.06 times the 64.99. And this is a job for my calculator. So I get $68.89 when I round it off. Okay? The other option is to just find 6% of that price. So if I found 6% of that price, so 0.06, that's 6% as a decimal. And if I were to find this, 0.06 times the 64.99, again using my calculator, I get this. I get 3.899. 4, and I could round it off there. The rounding here is a little tricky, and I have to do another step anyway, but that's what I add on to my price. That's the tax that I include, so I have to pay the $64.99 plus this tax, and so if I add those together once again on my calculator, I get $68.89. Okay, and now I'll round it to the 2 decimal places because I'm done the question. Okay, but once again, it's the same 2 steps. It's addition and multiplication. When I do my version over here, I do the addition first. I add the percentages and then multiply, okay, to get my answer. Over here, you find the percent and then add. So find the percent by multiplying and then add. I like doing the percentages first because it's easier to add or subtract those when they're not decimals. Okay?